All right, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying we have a 1.5 inch, that's our depth here, by 3.5 inch, our height. Board is also 18 inches long. We're actually loaded with a force of 120 pounds. We're trying to pull it apart in tension. We're going to try to figure out what's our average normal stress and our average shear stress on our section shown. Again, there are far more in-depth equations you will use as soon as things start bending, twisting, stuff like that. But for just average normal stress and shear stress, it's just force over area. Also, if we're at an incline, we should know our two equations in here. If our angle comes from horizontal on this, we can say that our shear, V, is going to get us to our force, let's call that F, times our cosine of our angle theta, where this theta is right here. Theta equals 30 degrees for us. If we measure that from vertical, it'd be beta. We'd use sine here. Typically, you're going to have from horizontal. But our other one we want is, what's our normal force? And it's just going to be our force times the sine of theta. Or again, if we came from vertical on our angle, we'd use cosine there. But I can use that to get my shear, my normal force. Then I need to divide by an area so I can get to a stress for everything. So let's get those two. My shear force, V, should be my force, 120, times the cosine of 30. Or this is 103.9 pounds. My second one that I want in here is my normal force. My normal force should again be my tension in there, 120, times the sine of 30. Sine 30. Or this is 60 pounds. With those two known, I need to get my area for this. But that area isn't just a straight up and down cut that I want. I need the area on that exposed. When I actually slice this, I have a cut that goes at a 30-degree angle. So let's draw a picture in here to help with this. So I'm going to make a triangle where that hypotenuse of my cut is going to be the hypotenuse in this triangle. I'm going to call this H for hypotenuse. So let's label it here, and I'm going to come up and label it on this picture as well, H. But I know this angle in here is 30 degrees. So we can get that one labeled. I also know my vertical distance in here. Oh, well, that's just 3.5 inches. So I can get that labeled, 3.5 inches, which really gives me enough between the side and the angle. I can find H. If we think back to our trig, sine is opposite over hypotenuse. So sine 30 would be 3.5 divided by H. Or H is 3.5 over sine 30. H is 7 inches. So my area then, I can say area should be, well, that'll be our depth times that hypotenuse. How much area is exposed along this cut. So 1.5, our depth times our hypotenuse, 7. This is inches times inches. We'll get square inches, 10 inches squared. If I have force and area, I can get to tau and sigma. Then my tau av should be my force, V, 103.9, divided by my area, 10.5. And just to totally document our units here, that 103.9, that's pounds for us. This area is in inches squared. Pounds per inches squared. We don't leave it written out that way. Pounds divided by inches squared. We want to always convert that to kind of the industry standard, PSI for that. So our tau av should be 9.90 PSI, which would be our first answer for everything. If this was in kips instead of in pounds, we'd use KSI for everything. But again, force divided by area, don't write it pounds per square inches. PSI, KSI is what we want. Sigma av, it's a really similar calculation for us. this should be our normal force, 60 divided by the area. I wrote 10, that should have been 10.5. I used it correct, thankfully. 10.5 inches squared. But 60 over 10.5. We again have pounds and inches squared, which means we again get PSI coming out for everything in here. Sigma Av. This time around is going to be 5.71 PSI, which is our final answer for our problem. Hopefully this was useful for us. If it was, hit those like and subscribe buttons. Stick around and watch more videos. Let's get you in there with JJ.